Okay, so I have here a video that's going to go over the calculation worksheet that I want you to do for this lab. Um, there are two parts to the assessment. One will be a quiz, and you have to watch the video to do the quiz, and you'll have to record down data that you get as you go along. And then after you get done doing the quiz, you'll hopefully be able to do this worksheet. I will go over. There's like 14 or 15 steps that I want you to go through for the worksheet, and I'm going to go over each one now, so it can be hopefully a little clearer. So let's go. As you watch me do the experiment, and if you go back and look, if you remember the quiz, there were when I added the hydrogen peroxide to the solution, the reaction took place, and it took a little time before it to turn blue, and that's because the reaction that's speed of how fast the reaction takes place. So what I wanted you to do is record the time it took to for each one of the samples to turn the blue. For instance, in the first sample, trial 1, I believe it was 133 seconds. Okay, so in this first table, you'll put all those guys, and you'll have this in seconds. All right, I'll let you guys do that, the rest of it. So, okay, for part B, what you want to do is, and there'll be a table on the next slide. But what you're going to have to do is find the calculations of I, because the equation for the rate is going to be rate is going to be equal to K, which we say K prime. If you read the sheet, times the concentration of I minus to whatever power times the concentration of H2O2 to whatever power, just like we did when we went over rates. Okay, and what we're going to do is we're going to say Y. We're going to determine X and Y, okay, from different concentrations of I and H2O2. So we need to find the concentration I's and the concentration H2O2s, and we get that from this table here. So the I minus, if you look in this table here, you can't see it. You see that it's right here. And so the I minus, the concentration I minus is equal to the concentration of Ki, because for every one Ki, there's one I. And here's the H2O. So let's find out. So let's do the concentration for this trial 1's I minus. Okay, so we're going to use the 1 mil of the 0.31 molar. So first thing we have to do is find out how many moles that is, and then this total solution for trial 1 is 10 mils. Okay, so you find out how many moles, and then you divide by 10 mils. Okay, so find the moles of Ki, and we keep on using this over to figure out moles from a solution. Use molarity times volume. Okay, so the volume is 1 mil, and the molarity is 0.3 molar, or moles per liter. So change the mils to 0.0 to liters, 0.001. Then multiply molarity times liters, and you get 0.0003 moles of Ki, or the same 0.0003 moles of I minus. Then you divide that by the amount of liters, 0.01, and you end up with 0.03 molar. Now, and we'll see that in the next slide where you put that. But then you'll do, for trial 2, now you have 2 mils, and then you do the same thing. So instead of having 1 here, you go 2 mils times 0.03 and so forth. Now for the H2O2, you do the same thing. You start out with, if you have 3 mils of 0.01, so you multiply, change this to liters, so it's 0.0003 liters times 0.1 molar. Okay, and that again, that's the same number, but it's for a different reason. So it's 0.003 moles, and again, every one of these is in 10 milliliters, so it's divided by 0.01 liters, and it also has a concentration of 0.03. And then for trial number 2 would be the same, 3 would be the same, 4 would be the same, but number 5 you have to do, instead of having 3 mils, it'll be 4, then 5 and 6. Okay, and then so let's go to the next slide. Okay, now so you put each one of those values after you've calculated them, you put them in that table in your worksheet. Okay, that'll give you. Okay, so let's go to the next step. So make sure you fill out each one of these guys from that table. We're going to use this down the road. Okay, this is really important. This table here is really important. Okay, all right. Next thing we want to do is, and we'll see why in a second, is we want to find out the amount of sodium thiosulfate, and that's what this is here. And if you notice, it's the same for all of them. And we want to figure out how many moles of the sodium thiosulfate is here. Well, that's an easy calculation. You just take the so remember, moles is equal to molarity times volume. Okay, so the volume is 10 mils, so make sure you change this to change the volume to liters, and the molarity is 0.02, and you figure out how many moles. Okay, so that's what you have to do for step number 3. Okay, now step number 4, you're going to take the data that you just had, and what you're going to do is you're going to find out how much I2 is produced. Okay, so if we look at our equation that if you look in the procedure, you'll see that the calculation says that here's the balance equation, is that for every 2 of the sodium thiosulfate, you have 1 I2. So in the previous slide, let's say you knew that let's say you had 0.0004 molar of the N2O2. The amount of I2 is going to be half of that. Okay. All right. Okay. So that's it for number 4. Okay, so and then what you're going to do is you're going to take the number that you got in number 4 and divide it by, figure out the molarities, and you divide it by its volume, 10 milliliters, or remember I have to get that in terms of liters, so then you divide it by 0.01, and then record that value, right? Okay, and that's an important number because you're going to use it in the next slide, and it's the same number for all trials. Okay, next thing you're going to do is you're going to figure out the change of I2 per time. So we're going to take the amount of I2 that we just found in the previous slide, and then we're going to divide it by the speed of each one of the trials. So the first one was 133. So you're going to take this number here that you found in the previous slide, number 5, and you can divide it by 133, and that number will go here. And then you do that for the other 6. Okay. Now, okay, so and this is the rate of the reaction. Okay, so All right. Let's put it together in the next slide. Okay. Now this is not in your worksheet, but you could easily set it up. So we figured out these two already, these two columns right here, and what we just found just now is this right here. And so what we're going to do is just like we did when we figure out rates is to figure out how the rate changes according to I. We'll look at how you'll notice that 1, 2, 3, and 4 you see changes in I but no changes in the H2O2. Okay, and then what we're going to do is look at change in H2O and keep the I2. And so we're going to look at number 1 and then 4, 5, and 6 and see how their rate changes. Okay. And then from those two things, this is that we'll find out the exponents that are associated with our rate law. Okay. So what you need to do is you need to find. So we have rate is equal to K times the I, concentration, to some power, and then H2O2 to some power. Okay, X and Y, and we'll see that's going to be different. And now, so what you're going to do is you're going to look at trials 1 through 4 to figure out this value here. Okay. And then what you're going to do is look at trials 1, 5, 6, and 7 to figure out this value here. And what I would like you to do is I'd like you to go to this site here, and you'll see what it does is it figures out, it'll help us figure out this value here. And so what you're going to do is you're going to go to this site, and then you'll see a table that looks like this. And then in the X column we'll just do the I first. You will have for columns 1, 2, 3, and 4's I value would be like 0.03 and maybe 0.06 or something like that. And then these other guys you just erase out. And you can just remove all these other ones. And then in this column here, you'll put the rate for each one of them. Okay, then you hit execute, and then you'll get something that looks like this. Okay, and what you're interested in is this value right here. All right. Okay. Now don't worry about this one. This is for this data over here. That B. So, and what you're going to do is record that B, and that B is going to be X. Okay. All right. Okay. So and then what you do is you do the same thing, kind of thing with the H2O2. Now instead of using columns trials 1, 2, 3, and 4, you're going to use 1, 5, 6, and 7. And then you're going to use the rate for 1, 5, 6, and 7. You're going to hit execute, and then you're going to get another B. Okay, and that'll be Y. And then you write those two down, and then you're going to go into the next step. Okay, so in the next step, you'll write down the B value that you got for the I and the B value of H2O2. And if you notice, it's probably not going to be a whole number, and we really would like to have a whole number. So round to the nearest 1 values, okay? So if you get like 1.2 rounded to 1, or if you get a value like 2.6 rounded to 3, okay? All right, next thing you'll do is you're going to write the rate equation. So it's going to be rate is going to be equal to K prime AI minus, okay, whatever B value you got for I here, and then you'll have the other B value for the H2O2 here. Okay. Alright, it should be H2O2. Alright, okay, so we're almost done. Next thing we need to find is the K prime. Okay, so K prime is easy to find. You just take rate. So K prime is going to equal to rate divided by these two values here. So what you're going to do is for each trial, so you're going to have rate divided by the IB and the H2O2B. Okay. Okay, for all the 7 trials, you're going to figure out this K. So what you're going to do is put the rate for trial 1, and then you have the concentration of I raised to its power times the concentration of H2O2 raised to its power, and then just calculate it, and that'll be your K prime for trial 1. And then you do the rest for the other 6. Okay, so there you go. So you do that. Okay, and then you just take an average. So add all these together and divide by 7. Hopefully they're fairly close together. Okay, and write that down. And then what you're going to do is write your complete rate law. Okay, so then it's going to be rate equals, okay, the average value of K prime, whatever that is, 0.02 whatever. Okay, and then times K times I to whatever power, and H2O2O to the same power. I'd like you to be careful about the units here, okay? So, for instance, if this was 2 and this was 1, so there'd be molar cubed, okay? So, and then your rate's going to be moles per second. Okay, so you have to figure out what this K value here is units. Okay, so that's going to take a little bit of thinking there. All right, then once you come up with that equation, what you're going to do is take some predicted value. You're going to plug in 0.04 for your I, your 0.05 for your H2O2, take your average KI, and then figure out the rate. Okay, so that's it. Hopefully that'll help you figure out how to do the calculations.